Hello. Walaikum Assalam. So, in this lecture, we are going to cover all the key concepts relating to every topic. So, the question says the function f is defined by this expression where x is greater than 2. Suleiman, what is the range of the function? How do we find the range of the function? It's just 1 mark question. State the range of the function.
Is it y is greater than 1?
Yes, you can write it's the function f of x or y that is greater than 1. We are always adding something to 1. So you are done with part 1. So obtain an expression for f inverse and state the domain of f inverse. It's a 4 mark question. Look, if you ask to find the inverse of the function, so just write your, I'm telling you a very cool method. If this is f inverse of x and let it is equal to y, f inverse of x equals y, then x must be equal to, when this inverse goes to the other side, it will be just function f of y. It's your f of y on the other side. So what is f of y? Your function is 1 plus, I'm scrolling up, this is your function 1 plus 3 over x. Just write the function over here. This is 3 over x minus 2. This is your x. So bring this 1 to the left side. That is x minus 1 equals 3 over x minus 2. Sorry, it's y minus 2, not x minus 2. It's y minus 2. So bring cross multiply y minus 2 equals 3 over x minus 1. Make the y subject. Y equals 3 over x minus 1 plus 2. Look, y equals f inverse x. So I approached f inverse x equals, just take the LCM of the side. So it is x minus 1. So it is 3 plus cross multiply. It will give you 2x minus 2. So final answer is 2x plus 1. It's 2x plus 1 over x minus 1. This is the expression for f inverse x. We have actually two approaches. You can make y the subject equal function, make the function equal to y, or make the x the subject. You can get the expression for the inverse. So domain of f inverse is the range. Look, write the thing over here. The domain, we are actually going to find the domain of inverse as well. So write this statement, domain of your f inverse is the range of f. The domain of f inverse equals the range of the f. So the domain of f inverse is, so domain of f inverse is also x greater than 1. The range of the function in part 1, remember this, the range in part
Yeah.
1, the range in part 1 is greater than 1. So the domain of the inverse will be the same. because the domain of inverse is a range of your domain function. So the domain of f inverse
Yeah.
is also greater than 1. So the next one, the function g is defined by g of x that is equal to 2, x minus 2 for greater than 0 values. Obtain a simplified expression for g f of x. This is of a composite function.
Just put f in g.
How do we solve this for g f of x?
You put f in g.
Yes, just g f of x. This is g. It's 2 times the function minus 2. What is your function? Write the function, that is 2, 1 plus 3 over x minus
X.
2 and minus 2. So take the LCM, make it simplified. X minus 2, now it will be like x minus 2 plus 3 minus 2.
The 2 cancels out, so it becomes 6 over x minus 2.
So inside you can multiply this 2 with this one, so it will be like 2x, it's 2x plus 2 over x minus 2, because 3 minus 2 is 1, and then multiply 2, so you will be getting your 2x plus 2 over x minus 2, and then it's minus 2. So now final expression would be, it's over 1. Just take the LCM over here, so it's your x minus 2, and that's equal to x plus 2 minus 2x, and it would be plus 4. So final expression would be 2x cancels 2x, it's 6 over x minus 2. This is your final expression, or simplified expression for g of f of x.
Yes.
So moving to the next one, that's very important, transformation of function. So look here, this function is intersecting at point 0.5. Diagram shows part of the graph, that is y equals sine a x plus b, where a and b are positive constants. State the value of a and one possible value of b. So we have an equation of y equals sine a to x plus b. If I'm taking this point, to mention that point 0, 0.5, I'm taking this point where this graph is cutting the y-axis, that is 0.5 y-intercept, and x is 0. So if I say y equals this expression, so I can plug my value of y, that is 0.5 equals sine of AB. Sine of a x becomes 0, so sine of AB, you can simply say it will give you the sine of AB. So if it is sine over here, and if I bring this sine to this side, so AB will be equal to sine inverse. So sine inverse of 0.5 equals AB. And sine, you can grab your calculator now and get the value in the radian modes. So sine inverse 0.5 will be pi by 6. It's pi by 6 equals AB, and this is your equation number 1. So we can do the remaining part over here. Now the second point, I'm taking this point, the x-intercept, that is 5 by 3. So just write 5 by 3 over here, 5 by 3 pi, comma 0. Now if y is 0, now this for second equation, if y is 0, then sine 5 by 3, I'm plugging in the value of x, the 5 by 3 pi, this is 5 by 3 pi a plus ab. This is my equation.
Okay.
Now we are moving to this section. So take sine to the left side and sine will become sine inverse. Remember this. Basically you need to cover all your key concepts regarding to any particular topic. So sine inverse of 0 equals 5 by 3. Now the right side of the equation is left just 5 by 3 pi a plus ab. In first equation our ab is equal to pi by 6.
Pi by 6.
Yes, you can write over here the pi by 6. So sine inverse 0, you can get the value sine inverse 0. So sine inverse 0 will give you, sine inverse 0 in radian mode will give you 0,
0.
pi and 2 pi, and move on. So the first value is 0 or pi, so we can take the pi. So write on the left hand side 0, on protector on D 0, pi lie on the same straight line. So this is pi, so the equation become like this. So 5 by 3 pi a plus pi by 6. If you solve this equation using your calculator, pi minus pi by 6 divided by this value, so the a is
11
giving
over
us the
6
value.
pi.
Yes, get your calculation. In my calculator it is giving me
11 over 6 pi.
1 over 2, just 1 over 2. Get the answer in exact form. So
Yes, sir.
a should be 1 by 2. Pi minus pi by 6 pi minus pi by 6 divided by 5 by 3 pi, so a will be 1 by 2. And for the value for the b, look, for value for the b, we have the first equation ab equals pi by 6. If ab equals pi by 6, then the value for a is 1 by 2. So my value for the b will be pi by 6 times 2. So it will be pi by 3. So it is pi by 3. So my value for the b is pi by 3. You can scroll. This is your a and this is your value for b. So we are done with part 1. Any problem in this part?
Just a second.
Okay.
Could you go up?
Yes. Abhi, you should write all the some basics knowledge of every topic we are touching over here. You just need to understand the concept behind this.
Okay. Okay.
Okay, so moving to the next one, that's very important. Another curve with equation y equals f of x has a single stationary point at the point p comma q where p and q are constants. This curve is transformed to a curve with equation this. Find for the transformation of the curve, find the coordinates of the stationary points giving to our answer in terms of p and q. This is actually the order of transformation. So you can write over here, this is actually the order of, this is the order of. This is the order of transformation. So here order of transformation matters a lot. You have to follow the order. This is order of transformation. Number one, if I say, okay, the first is y1, the transformation, I am following some particular order. y1 equals the function f of x, and that is 1 by 4 of x. So if something have a scale factor in 1 by 4, it is actually the reciprocal. It is a stretch by factor 4. So you have to describe the type of the transformation. So just write its stretch by factor 4. This is a stretch by factor 4 parallel to y-axis, parallel to y-axis. So this is one. Now step by step I will write the other transformation. So the next transformation, suppose that is y2, and here now I will write the function, this is 1 by 4 into x plus 8, and now 8 is being added. If something is being added, so you can write this is a transformation of the column vector. You can describe it's a transformation. This is a transformation by vector. Just write the vector. If it is plus 8, it will be moving to the negative left side. It will be the negative one. Negative 8, 0. This is your second transformation, y2. So so you can say if it is your in first, in here the stretch factor parallel to y-axis. So here you should write your p. Your p is actually the 4p, because he is asking you to give the values for the p and the q. So this is 1 by 4. So 1 by 4 means stretch factor by 4. So p is actually 4 times p. Now negative 8 is also attached to it. So you can say if at the first transformation it was 4p, and now in the second transformation it is 4p, but 8 is being subtracted from it. So 4p minus 8 will be our second transformation. We have to follow the order. Order of transformation is very, very important. So in third case, you can write the equation becomes y3. The function was y equals negative 3. I am describing each and every transformation being applied on the function. So first 1 over 4. 1 over 4x mean the function has been stretched by factor 4 parallel to y-axis. In second transformation it was x plus 8. So that was transformation of negative 8 under column vector negative 8, 0. So now my 4p becomes 4p negative 8. Now the third one is negative 3. So its function is multiplied by negative, stretched by factor parallel to y-axis. So just write this is negative 3. Write the function 3. You cannot describe negative 3 first. You have to follow the order. This is order of transformation. Students write the transformations correctly, but they ignore the order. If they will ignore the order, then they will be in a problem. So negative 3 the function of that is given, and it is 1 by 4 of x plus 8. So you can say here we are observing the transformation. It's a stretch factor by -3. Stretch by factor. Make it simplified. -3, and it is parallel to y-axis. So this was your Q, the third one. Look, for the transformation curve, find the coordinates of the stationary points and giving your answer in the terms of P and Q. So now my Q, if this is my Q and my Q is -3 times Q. This was the last order of the transformation where it has been applied to the function. So you can simply say, okay, now I am done. Now write the coordinates of P and Q. You can simply say, okay, this is, first is 4P minus 8 comma -3Q. So this is my order of transformation, and we are done with the question. I hope you understand this. Another curve, the function y equals f of x has a single stationary point at the point P and Q. So we need to find this point, the P and Q, under some specific order of transformations. Where Q and P are constant, this curve is transformed to a curve with equation y equals -3. This is a transformation. This is telling you the complete story of all the cases that I have already told you. 1 by 4 of x plus 8. So this is actually the order for the transformed curve. Find the coordinates of the stationary point, giving your answer in terms of P and Q. Silly mistakes will deduct your marks, so you have to be very careful.
Yeah.
So this is the order of transformation, P to 4P, and this is y1, this is y2, and this is y3, and finally we obtain our 4P minus 8, 3, -3Q. So moving to the question, next question. A curve has equation this. So what are you doing? Find the equation of the normal to the curve at point A 4, 3, giving your answer in the form of y equals this one. So first of all, take the derivative of the given equation.
First you differentiate it.
Yes, differentiate the equation. So this is dy by dx. What is the differentiation of the given curve? It would be 1 by
X
2.
power -12.
Yes, it is 1 by 2 into 2 x power -12, x power -12, and that will be cancelled out. So finally I can say it's my 1 over root of x. Is it okay?
Then you find the gradient by substituting 4 in x.
Yes, so what is the gradient?
1 over 2.
1 over 2, yes. So you can say gradient of tangent. Your gradient of tangent is 1 over 2. So what will be
Then you
your,
find gradient of normal,
yes,
which is,
what is
we take
your,
negative reciprocal.
yes, take the negative reciprocal. So this is
It's
negative 2.
-2.
It's -2 now. You have a point. You have a point at gradient of the normal. Find the equation of the normal to the curve at the point 4, 3, and we got the tangent, gradient of the tangent and the gradient of the normal. Now we can directly apply the equation. What is the equation of the normal? Abir, this is y minus y1 equals m into yes, you need to participate. So it's y minus 1, it's y minus 3 equals gradient of normal, that is negative 2 into x minus x1. So x minus 4, if you solve this, so you are going to get this is negative 2x and plus 8. So it is y minus 3. So y equals negative 2x plus 11. This is our required equation of the normal to the curve. That was easy.
Yeah.
So the next one, find the rate of increase. Find the rate of the increase of curve y equals 2x to this one in such a way that the rate of increase of the x coordinate is 3 centimeter per second. Find the rate of the increase of the y coordinates at a. You just tell me the formula. You are given the dx over dt, that is given the value that is 3. So how do we calculate the rate of increase of the y coordinate? Just tell me the formula. Yes, any one of you. Which formula you are going to get this thing?
Uh, you have to find dy by dt. So you just write dy by dx into dx by dt equals dy by dt.
Great. So I'm going to write dy by dt. So dy by dt, that would be equal to dy by dx multiplied by dx by dt. So dy by dx, what is dy by dx derivative?
You have to differentiate the equation to get dy by dx.
Yes, and it should be x. When you put 4 in the derivative,
1 by
it's
2.
1
Yeah.
by 2. It's 1 by 2. Yes, it's 1 by 2. So it's 1 by 2. Just get it's 1 by 2. And dx by dt is 3. Just it's 3.
It's given. Yeah.
Yes, it's given. The final answer is 3 by 2.
1.5.
Yes, 3 by 2 or 1 by 2. You can leave it in fraction as well. So for this one, the next thing. Read the question.
We have to find dx by dt in this.
Yes. At point moves down the normal. Find the rate of change of its x coordinate. So we are going to find. Look, at a the moving point. At a the moving point suddenly changes direction and speed and moves down the normal in such a way that the rate of decrease of y coordinate is constant at phi. So what is given? Abhi, what is given? What is the given value? That is dy over. And what is the value? What is this value? Plus 5 or minus 5?
Minus 5.
It's minus 5 because this is a decrease. So when you have a decrease, so it should be negative 5. So this is negative 5. So you have your equation. So you have your equation, that is y equals negative 2x plus 11. We obtained the equation in the previous part, negative 2x plus 11. And what is the derivative of this? So dy over dx. So if you want to get your derivative dy by dx, so it will be negative 2. Now dx over dt, we want to find that. If it is dx over dt, it will be like negative 1 by 2. It's negative 1 by 2 dx over dy. So write the formula first. So you can write dx over dy, dx over dy times dy over dt. So we have dy over dx, that is negative 2, but to make the chain
So you
rule,
flip it, so it becomes minus half.
yes, it will become minus half. So it is minus half times the negative 5. So negative negative becomes positive. So the final answer is 5 by 2. So 5 by 2, the rate of decrease. So find the rate of change in x coordinate. So this is dx over dt. So this is the final answer for this part.
Yeah.
This question is very important. The question number 10 is very important. State the size of the angle ACO in radians. How do we find the size of angle ACO? So first write the angle, reflex angle A.
You first find ACB.
Look. You need to get this thing, reflex angle. So here we are going to get the reflex angle. Which reflex angle? AOB. Reflex angle AOB, that is actually 2 pi minus 2.8. This is 2.8. And suppose that the angle is x. So 2 pi minus 1.8, 2.8, that is equal to actually 2x. If this is x and this is x, if this is x, this is also x, so it is equal to 2x. So your x will be equal to, your x equals pi minus 1 by 4. 2.2 pi 2 cancels 2, so it is actually pi minus 1.4. Do you understand why I write pi minus 1 by 4 directly? So it will be actually 2 pi minus 1.8 divided by 2. So it will give you pi minus 1.4. It's actually 2.8, sorry. It's 2.8. It's 2.8. So it's 2.8. When you divide it with 2, you are getting this thing. So, but now
1.4.
So it's pi minus 1.4. So triangle AOC. Now focus on triangle AOC.
So isn't that just 1.4 divided by 2?
No, it's 2 pi minus 2.8 divided by 2. This is equal to x. So when you divide 2 pi with 2, it gives you pi. It's giving you pi. 2.8 divided by 2 is 1.5. So my x value here, my x value is pi minus 1.4 just. And triangle AOC is isosceles. Your triangle AOC is an isosceles triangle. So if it is isosceles triangle, so now the unknown value is the sum of, in triangles, angle sum is isosceles triangle.
You have to find AC or not AOC.
Wait. This is a triangle. I'm using the triangular concept. So in triangle AOC, that is triangle AOC is isosceles. So two angles are same, 2y. The third angle x is pi by pi minus 1.4, and all these angles add up to 180. So these three angles are equal to pi. So you can simply say 2y equals 1.4, and your y, that is your required angle, is 1.4 divided by 2, and it is 0.7 radian, and your y is actually the angle ACO. ACO, you can write this angle as y. So ACO equals 0.7 radian. So this was my approach to get our ACO angle. Now tell me, find the capital R in terms of small r. Moving back to the equation, this is capital R, this is small r, this is x. How do we find this r? We can actually use the trigonometric concepts. We can use the sine rule and we can get the value for the r. So I'm writing over here. So you can say using sine rule, I can calculate, look, this is r over sine r, and opposite angle is x, and x is, look, and x is pi minus 1 by 4. So you will write this is pi minus 1.4 equals, the other side is the small r, and angle, we found the y. If this is y, this is y, and our y is 0.7. So you will write over here sine of 0.7 radian. So you are supposed to get your capital R. Your capital R will be in terms of R. So that would be R into sine pi minus 1.4 divided by sine 0.7. You can grab your calculator and give me the answer. Your answer must be 1.53 in terms of small r. So till 3 significant figures you will be getting greater decimal points, so you can stop your answer till 3 significant figures, and this is the value of r in terms of small r. In part B, he asked to find the value of capital R in terms of small r. So capital R, small r has been done. We are done with this part B also. Any problem? I use just
No.
trigonometric concept, that is the sine rule. Now, the 7-mark question, the most important. Very, very important. Find the area of the shaded region in terms of R. So first we have to make a work plan for that. So shaded area, I am writing that line, the shaded area. That will be equal to, go back to your diagram. We want to get this shaded region. We are supposed to calculate this shaded region. If you get the area for the complete circle and the white area, the triangle, the segments, then we can easily get our shaded region. So I have a working plan for this thing. It is of a 7 mark.
First, you find the area of the sector.
Yes, just write your plan over here. So you can say area of circle. If I calculate area of circle and then I subtract area of sector, and then area of segment, 2 times area of segment. That is AC or BC. This is the work plan you have to show to the examiner. BC or AC segment. So look, this area, and complete circle. So look, now area of circle will be equal to pi r square. So write pi r square minus area of sector. The formula for the area of sector is 1 over 2 r square theta. This is 1 over 2 r square theta. So write first the angle r square theta.
Yes.
Minus, now minus 2 times. Now execute your work plan for the examiner. This would be like 1 over 2 r square theta, that is pi minus 1 by 4. We have already calculated this, pi minus 1 by 4. And then we have triangles, actually 2 triangles, that is 1 over 2 r square sine theta. that is r square sine theta, and theta is pi minus 1.4. So finally going to the values, this is pi r square. Here again you have to show your area in terms of small r. We don't know the value for the small r, so the answer will be in terms of small r, pi r square minus 1 over 2 theta. So just write over here, this is 1 over 2, and capital R, we have the value that was 1.53. So you can write 1.53 and its square, and the theta was 0.7. So in radian, so this was 0.7. So now the next thing, this is 2. Put a bracket there. So you have 1 over 2 r square, 1 over 2 r square into pi minus 1 by 4. This is pi minus 1.4, sorry, this is pi minus 1.4, and then you have to subtract again 1 over 2 r square, 1 over 2 r square sine of pi minus 1.4, pi minus 1.4. So making calculations short, you have to use your calculator over here. So take r square common from everywhere. You can take r square common from every side from this. So you can say simply this would be pi minus 0.7 into the value of r, that is 1.53, that is 1.53 minus pi, 2 cancels 2, so it will be giving you minus pi plus 1.4 plus sine into pi minus 1.4. So the answer of this using your calculation should come like 0.747 r square till 3 significant figures. So area is always in square, so you can get this expression. The rest is the calculator calculation. So any question over here?
No.
Okay. So the question number 11. First thing is a 4 marks. Just a second. I need to plug my laptop charger. You start doing this part. So how do you verify that x coordinate of r is 3 by 2 and the y coordinate of r?
You differentiate and find the turning point, which has to be 3 by 2, and then you substitute that into the equation and find y.
Yes, so you need to find the derivative of that thing. Dy by dx will be your 1 minus this is your x is 1, and when x is 1 and then x is 2, so 2 times 2 4. So just take this expression to the other one. You in this part you just need to differentiate. So finally your differentiation should, what is your differentiation? One minus 2, look, into 2x minus 1 negative 2. When you do the differentiation it becomes 4, and it's 2x minus 1, it becomes negative 3, and multiply with the derivative
Yes.
of the bracket. So it is your 1 minus 8 over
To 2x minus 1 power 3
yes, this is 2x, bring this to the down, so this would be 2x minus
cube.
1 to the power 3. Now at stationary point your derivative is 0, so when your derivative is 0, so it is 8 over 2x minus 1 whole cube, that is equal to 1. So by expanding this you are going to get your, look, 2x minus 1 whole cube equals 8, and cube root is 2x minus 1 equals 2. Take the cube root on both sides, cube root to this side and cube root to this side, so your x is coming like this, 3 by 2. So yes, it has been proved the x coordinate is 3 by 2, and you can also get the y coordinate of as well, that is x is, when x is 3 by 2, when x is 3 by 2, x is 3 by 2,
Yeah.
and plus that is 2 over 2 times 3 by 2 minus 1 whole square. So your y coordinates will be like 2. So you obtain both of the, you proved actually the x coordinate is 3 by 2. It has been to verify, told in the question you need to verify that x coordinate of capital R is 3 by 2 and find the y coordinate of R as well. So the next part, to find the set of the values for the shaded region, and it is of a 6-mark question. So part B, where x, two values are given. At P x is 1 and at Q x is 2. So when x is 1, so you need to get your value, the y equals 1 plus 2 over 2x. So 2 into 1 minus 1 whole square, that is giving you 3. Use your calculator to save the time. Y equals 3. So the coordinates for the P are 1, 3. So moving to the next one for Q. At Q, you can say, okay, at Q. For Q, x is 2. For Q, x is 2, and your y will be 1 plus 2 over 2x. So 2 times 2 minus 1 whole square. Grab your calculator and get, that is giving you 20 by 9. So the Q has coordinates now. Your Q has coordinates like 2, 20 by 9. So we are done with this. Now we are going to get the shaded region. Now we are going to get the shaded region. Shaded region will be area of trapezium. There is a shape, look, there is a shape, and that is a trapezium. This is the shape, this is a shape. So we need to get the area of the trapezium and subtract the area of the curve. You will be getting you will be getting your area of so write area of trapezium. Always give the work plan. Area of trapezium. So you have a shape that is trapezium. So area of trapezium minus area under the curve. Area of curve. So you will be getting your area of shaded region. So look, area of trapezium is 1 over 2 into height into sum of parallel side. Height is 1 and parallel sides are 2. One is 20 by 9 and the other is 3. So this is your area of trapezium minus you need to do integration. So 1 limit, you have a limit 1 till 2 in the area. So that is your integration is x plus 2 into 2x minus 1 whole power negative 2. Now do the integration. The left hand side will give you the answer 20 plus 9. Use your calculator. So it would be like 47 over 48 minus you need to do the integration with modulus. So the integration would be like x squared over 2 plus 2 into 2x minus 1 whole power negative 1 divided by negative 2, and the derivative of the bracket is 2 and negative comes down. So the limits are 1 till 2. So upper limit in x, so you need to do the your limit. So it is upper limit in x minus lower limit in x and subtract it. So when you are doing all these calculations, the final answer would be 4 over 9. So this is your area. You can get, this is your answer. So you can do calculations by yourself. So this was the part number, last part of I think this paper, the B part of the question. So find the exact value of the area of the shaded region. I just 2 points were given. Look, 2 points were given. First point was x. Look here, the lines x equals 1. We have these 2 points, x equals 1 and then x equals 2. Actually this x1 and x2 are the limits, and we use the concept of our integration with limits. So we proved and we get the idea is area. So verify that x coordinate of capital R is 3 by 2. So we are done over here. Okay.